All right, so the first thing that we're going to do today, I'm going to go over how your setup should be for your notebook. So the title is the 1.5, the using formulas in geometry. So that's what we did yesterday. And it says cut and throw away, so don't do the throw away part yet. Okay, we're just going to cut that part off. And then once you cut that, you should see the perimeter and area piece is prevalent there. And then we are going to glue that onto our page. All right, and then the second one that we did was our circle. So because this is flat, we can just put that right on the back. And then you can decide if you want to cut out the circle and then the box, or if you want to keep that all as one thing. If that fits on your page, you can decide. Because for some of you, if that fits on your page and you'd rather do that than cut out the circle and the box separately, that's going to be completely up to you. And again, don't get up and throw your scraps away yet. Okay, you can ball them up. Okay, so that's how our 1.5 is set. If you did miss your notes for 1.5, I did just go ahead and I scanned in the copies from this. So when you get your blank copy, you can just go ahead and write those in from your Google Classroom. Okay? So for today, we're going to do 1.6. So we're just going to flip to the next page in our notebook. And while I'm going to get my notebook, what you can do is you can start to fold your green sheet. What's going to happen is these are going to meet in the middle. Okay, so kind of feel out folded, you can go ahead and put up your title. Yep, you're just going to fold both sides towards the middle. And it's okay if they overlap a little bit. That's not a problem. So you can kind of see too, like on the back, you'll have that part blank. And 1.6, what we're learning about today is the midpoint and distance. In the coordinate plane. Okay, so the midpoint and the distance in the coordinate plane. Midpoint is something that we have talked about before. Jillian, can you just remind us what is a midpoint? Okay, so it's the on a line. Okay, if the line has 2 points, the midpoint is the point in between those. And she said that it was the in-between. So whenever you have a midpoint, what does it do to your segment? Cuts it in half. That's right. So you have 2 congruent segments. Okay, so the distance formula might be something you've already done before. Do any of you know it by heart? It is, yeah, it is really long. And it has a square root in it. So if you're finding the distance between 2 points, it's going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. And the reason why we have x2 and x1 is because when we're doing this, we'll actually have 2 points. So one of the points is x1, y1, and then the other point is x2, y2. Okay, so we're going to use this to find the distance. Between 2 points, which we call x1, y1, and x2, y2. The cool thing about the distance formula is even though I have written here that you do the second minus the first x, if you switch those around, as long as you do the same thing for the y's, it wouldn't matter if you did x1 minus x2 and y1 minus y2. Okay, so you get to pick what your x1 and y1 are and what your x2 and y2 are. Now the midpoint is used to find that point that's in the middle. So the midpoint formula is going to give you a coordinate point. Okay, so we know that a point has parentheses. So the first part of the parentheses is x1 plus x2 divided by 2, and then we have our comma, and then we have y1 plus y2 divided by 2. Okay, so the midpoint formula is going to find the middle in between 2 points. Okay, so this is going to be to find the middle point between 2 points. And again, those 2 points are going to be x1, y1 and x2, y2. Okay, so one of them we're finding the distance. We're finding the length. The other one we're going to be finding the point. In the midpoint formula, you can tell that what you're doing is adding two things and dividing by 2. All we're doing is we're finding the average between those two. Okay? So we're going to add them together. We're always going to divide by 2 because we're just adding two things together. So it's the sum and then divided by 2. Okay, now in the center, we're just going to read a couple things first. Okay, so these are just important things to know. So what you're finding is the distance between 2 points. Okay, so something that you might see is like, what is xy? What is the measure of xy? What is the length of xy? Okay, if you have any of those questions, you can use the distance formula. Now, we had one of those questions on our quiz where you had to find the distance, but it was on a number line, not in a coordinate plane. We're actually going to talk about the coordinate plane in just a second here, because this is what we have. This is our coordinate plane. Your answer is always going to be a positive number. And again, that's because you're finding the distance. Okay, so we're just going to go back to our note sheet real quick and write down a couple of notes about the coordinate plane. Okay, so a coordinate plane is a plane that is divided into 4 regions by a horizontal line, which we call the x-axis, and a vertical line, which is what we call the y-axis. Okay, so a coordinate plane is a plane that's divided into 4 regions by a horizontal line, the x-axis, and a vertical line, which is the y-axis. So we're just going to draw a small example of that. So here's your y-axis, here's your x-axis. And then each one of those 4 regions is called a, well, do you guys know? Yes, it's called a quadrant. Do you guys know how to name your quadrants? So yeah, it is. Yep. So the quadrant that's positive, positive is the first one. Okay, so you go positive x, positive y. Okay, and then you work your way counterclockwise. So this would be quadrant 2, this would be quadrant 3, this would be quadrant 4, and you'll see that they're named with the Roman numeral numbers. So 1, 2, 3, and then 4. 4 is the straight line, and then the V, that's number 4. Okay, and then the coordinate or location of a point is given by an ordered pair. Okay, and the ordered pair is x comma y. Okay, so every ordered pair is going to start with x and then end with y. Okay, so x is the distance horizontally, y is the distance vertically. Now, if we have more than one point, which we are going to have today, then what we're going to do is label them x1, y1, and x2, y2. Okay, so before we start our examples, go ahead and look here at the steps. Looks like that one was mislabeled. Okay, so it says finding the distance, identify x1, y1, and x2, y2. So that's what you'll do first. So these are like your steps. Okay, so after you identify your x1, y1, your x2, y2, you're going to substitute those into the formula and then use the order of operations underneath the radical. And then your last step, which let's go ahead and change this to 4. Okay, your last step is going to be to take the square root or leave as a exact value, which the exact value is going to be a radical. Okay, so we'll practice both, taking the square root, leaving it as a decimal, and leaving it as a radical. So now for number 1, it says find the distance between points A and C. So the first thing I'm going to do is I'm going to figure out the coordinates of A, and then I'm going to figure out the coordinates of C. Okay, so I want you to go ahead and do that right now. Okay, remember your X term goes first, your Y term goes second. Yeah, if your grid isn't labeled, then we're just going to assume that it's 1. Technically, you should have one of these labeled here. So for A, you're going to find on the X, you go over 1, 2, 3, and then how many did you go down? 7. 1, 2, 3, 4, 5, 6, 7. So 3, 7. Okay? Oh, thank you. -7, because we went down. Perfect. Okay, now for C, Matt, what did you get for your X value? Yep, 0, because you're not going anywhere left or right. And then we went up how many? 1, 2, 3. Right, now like I said before, it doesn't matter what you label as your X1, Y1. So you can choose. I'll usually just go in order. So whatever's listed first, I'll make that my X1, Y1. I'll make this my X2, Y2. And then we're going to substitute into the formula. Okay, so when you substitute in the formula, it is right here. So your distance is going to equal the square root of, and then I'm going to do x2 minus x1. So I have 0 minus 3 squared, and then plus 3 minus -7, which if I have minus a negative, yep, it's going to turn into plus. Just be careful about those, because those can definitely be an easy thing to miss. Okay, now the next part, I actually do in my head, and I recommend that because sometimes we just trust the calculator. We don't even think about what we're plugging in. So when we have 0 minus 3, it's obviously what? -3. When you square -3, what do you get? 9. If you do not put your -3 in parentheses, if you were just relying on your calculator, it would give you -9 because it follows the order of operations. So this is going to be -3 squared, which is going to be 9, and then plus, and then 3 plus 7 is what? 10. 10 squared is 100. Okay, so if I add those together, 109, this would be an exact value. Okay, and then we are going to go ahead and round this. Okay, so we're going to take the square root of 109. And then we'll just round this to the nearest hundredths place like we did yesterday. Okay, so you did 10.44, and this would just be your units. Okay, so sometimes you'd have to find the 2 points. Other times the 2 points are just going to be given to you. Like in example 2, okay, when you're finding the distance between these 2 points. So again, I would go ahead and label those first. Okay, I'm going to give you time to plug those in. And then simplify. All right, let's see how we did. So when you guys look at mine, I did write it out step by step. So it's important that when you are subtracting negatives that you do change it to plus a positive. So -3 plus 1 became -2. When I square -2, I get a +4. Anytime you square something, you should have a positive. Notice how both of these are squared. If both of these are squared, is the number underneath ever going to be negative? No, because you're always going to square them before you add them together. Okay? So once you get to this step, the step where you're adding the two numbers, if there's a negative there, that's a sign that you may have just plugged it in and then your calculator didn't understand what you were trying to do. Okay? So +4, +64, which is 68. So a lot of you probably just went ahead and took the square root of 68 and said that was 8.25 units, right? Okay, and you did have to round that because you had 8.24, but the number after the 4 was a 6, so then you round up. If you want to write this as an exact value, then what you have to look for underneath the radical are perfect squares. Do you guys remember that? Simplifying radicals with your perfect squares? What is like a perfect square? Okay, 25 is a perfect square. Danielle, can you tell me why it's a perfect square? And when you take the square root of 25, the answer's 5, but what's special about that? Right, it's a whole number, right? Okay, so any number you can take the square root of and you get a whole number is a perfect square. So what we want to do is see if any perfect squares go into 68. Do you guys know the lowest one that you would try to see if it went in there? Nope, because if do the square root of 8, is that a whole number? 9 is one, but there's one lower. 4. 4 is the lowest one. Okay. 1 and 0 are the lowest numbers, but the reason why you wouldn't check for 1 in that is because it would just be 1 times the number. Yep. So when you're looking to take something out, 4 is what we're going to try. So does 4 go into 68? Yeah. How can we confirm that? Okay. So yeah, let's do it. So let's do 68 divided by 4. Anakin, can you get that for me? Anakin's going to help me out with that one. Yep, 68 divided by. So we're seeing if 4 goes into 68. Good. Okay, so 4 goes in there evenly then, right? Because I don't have a decimal. So what you can do is you can rewrite this. Okay, so we're just going to rewrite this as the square root of 4 times the square root of 17. So remember, you can always break up square roots using multiplication. So the square root of 4 times the square root of 17. And then once you write it like that, it's a lot easier to simplify. When you do write out the multiplication, put the perfect square in front because that's what you're going to simplify. Because what is the square root of 4? 2. So then your exact value would be 2 root 17. Okay, so that's your exact value. And then this would be your rounded value. Yeah, you should practice both because you should know how to do. You will have to know how to do both. Yes. Okay, for example 3 and 4, we're going to look at the midpoint now. Okay, so we're going to switch gears a little bit. So let's review our important points. So we have to know the midpoint is in between two other points. Okay, it's exactly halfway between those 2 points. We can think of it as the average of the x-coordinates and of the y-coordinates. And make sure that you understand that your final answer is going to be a coordinate, which means when you do your final answer, you're going to have the midpoint, which will be x comma y. Then if you're having trouble too when you get home, you can follow these steps. So the first thing, pick out your x1, y1, x2, y2. You're going to use your formula and substitution, add the terms and divide, and then you're just going to leave as a coordinate. Make sure that you do simplify if needed. Yep. No, it'll be directly on the line. So we'll do those two together. So first we're going to find coordinate B. So that would be over 1, 2, 3, 4, 5, 6, and then up 1, 2. So B would be 6, 2. Okay, so D I'm going to the left. So 1, 2, 3, 4, 5, 6, 7, 8. So I'm negative 8. And 4. So this is going to be negative 8, negative 4. And then again, you can choose what order you want to do these in. I just always will go x1, y1, x2, y2. Yes, so if you wanted to label this one x2, y2, and this one x1, y1, that would be perfectly fine. Yep. The key is the x1 just has to be with the y1, and then the x2 has to be with the y2. Okay, so remember our final answer is going to be a coordinate. So we're going to add the x1, which is 6, to the x2, which is negative 8. Divide that by 2. And then we have 2 plus negative 4, divide by 2. Okay, this is something else that we should be doing without our calculator if possible. So if you have negative 8 and you're adding 6, right? Yep, then that means you're still down 2, so it would be negative 2 over 2. And then 2 plus a negative 4 is negative 2. Negative 2 divided by 2. Negative 1. So negative 1. Okay, so this is your midpoint. Now, if you have that on a graph, what I would do too is I would just check that. So if I do negative 1, I'm right here. And I would just kind of eyeball and say, does my answer make sense? If I have a line going from D to B, does that look like it's halfway? Yes. That way if you get something, like if you got something that was over here, you'd be like, oh, wow, that isn't even on my line. And that would give you just a clue. Okay, I need to go back and see where my mistake was. Okay? All right, so I'm going to give you a minute to do example 4. Okay, so notice that this one is a little bit different. So they tell you that M is the midpoint, and it says find the coordinate of B if the coordinate of A is 3, 7, and the midpoint is 5, 10. So notice here that they give you x1, y1. They give you the midpoint, but what you have to find is coordinate B. Okay, so B is our unknown. So what we have to find is x2, y2. So in order to do that, we're going to use our equation. We know if we add the two x's together and divide by 2, we get the x coordinate of the midpoint. So what we're going to do is we're going to take our x1, which is 3. We don't know what our x2 is, so I'm going to write it as x2 divided by 2. And then what part of the midpoint does that equal? The x, right? Which is the 5. Okay? Based on that, do you guys think you can set up the equation to find the y? Okay, so to find the y, we have y1 plus y2 divided by 2. So do we know what our y1 is? Yep. Y1 is going to be 7. Do we know y2? No. Do we know what the final y value is going to be of our midpoint? Yeah, what's the final y value? 10. Okay, so now what we're going to do is we're going to solve these, and I'm going to help you do that. But I also want you to have some kind of visual representation. So it tells you here M is the midpoint of AB. So sometimes it's just helpful to go ahead and draw your segment AB and put M in the middle. So they give you A is 3, 7. And I know this is flat, and obviously 3, 7 is not going to be flat with 5, 10. But this is just going to give you a little bit of perspective of what you have. Okay, so this is the 510, and then you don't know what this is. Okay, it might also be helpful to graph that on your coordinate plane. Okay, so if I want to solve that for x squared, can you guys tell me what I have to move over first? The 2. Yeah, do you know how to do that, Griffin? Multiply both sides by 2. So if we multiply both sides by 2, Ryan, what happens on the left side when we multiply by 2? That yep, that's okay. So the 2 and the 2 are going to cancel out, because if you're multiplying by 2 and dividing by 2, those are inverse operations, right? Multiplying and dividing by the same value. So multiply by 2 divided by 2 cancels out to give us 3 plus x squared. And then 5 times 2 is 10. So now when I want to get x squared by itself, Nia, what am I going to do to both sides? Uh-huh. Yep. And then it's just x2. I don't want you to think it's x squared and then try to square root it. So this means that the x coordinate of b is 7. Now your process for solving the second one is pretty much going to be the same. So go ahead and do your first step. And then your final answer is going to be written as what? A coordinate. Okay, so your final answer is going to be written as a point. Okay, so just like we did before, Abby Adams, what are we going to do first? Good. Okay, so the first thing is to multiply by 2. The reason why, when you have that fraction, you can always multiply by the denominator to get them to cancel. Okay, and then Christina, if I want to get y2 by itself, what am I going to have to do here? Good. Subtract 7 from 20. So then y2 is going to be 13. So then my final answer, the coordinate of b, is going to be 7, 13. Now, again, if we wanted to check that, you could go ahead and just graph it. So if you graph 3, 7, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay, you can kind of eyeball that, and then, well, 510 will fit. 3, 7, 5, 10. That's actually going to be really small in that graph. Okay, so that would be just a good way to make sure that your answer is correct. All right, so then what we're going to do is we are going to glue this in our notebook. Okay, and we're just going to put it underneath the notes that we took. If for some reason it doesn't fit under the notes that you took in yours, and you want to put it on another page, just make sure that you flip the page. Don't put it on the back of this one, because this is a foldable that opens up. And if it opens up, we never want those on the back side. Okay? And then I'm going to give you some time right now to work on your homework. I'm going to let you write that down, the 12 through 20 on page 47. I'm also going to put up the textbook for you. Okay, so I'll give you a minute to get that written down. Just write it down. And then I will put the book up there. And then will you have out your homework from yesterday? I'm just going to come around and check that.